Okay, so picking up again where we left off, we just finished the cost crash analysis and looked at the cost crash curve. Now we're just going to touch a little bit on fast tracking. So again, fast tracking is that technique for activities that would have been performed sequentially, one after the other in your schedule, using the original schedules performed. Now we're going to do it in parallel. In other words, fast tracking a project means the activities are worked in a simultaneous fashion instead of waiting for each piece to be completed separately. So the critical path method is the scheduling technique often referred to as just CPM, as you see on this slide. It is a precedence diagramming method, right? PERT, which is referred to on this slide, is a risk management approach to minimizing the fluctuations in schedule activity durations and also in activity costs. And you'll see that as a common tool between those two management approaches. My one caution that the author included with this book was that CPM or PERT ignore resource utilization and availability. I will just share with you that I think the term ignoring resource utilization is a bit tough, a bit firm. For example, durations are addressed based on the resources available. And any good project manager is always building a resource histogram, a resource bar chart, so they know where the resource is at. Later we talk in normal critical path method, project managers will do resource smoothing or resource leveling. And with PERT, the optimistic or pessimistic times are normally used, right? But for the most part, the most likely will account for resource availability. So I just think that's a little strong. I wouldn't go there with my studies, but the author's allowed his own opinion. But still, I agree with the point, which is that resourcing isn't the primary input. Now, so time constraints, just to touch on that some more, can be adjusted, as we've seen in the compression techniques above, but of course at a cost, right? Often, however, the resources that may be added to the crashing technique have diminishing returns. So I can't just keep adding personnel and cutting time, of course, right? That law of diminishing returns. So all knowledge areas, frankly, I also want to say are constraints on the project. A constraint by its very definition limits your options, right? And so, in fact, in project management, I've always shared that there are 6 key constraints that you always want to have in front of your mind: cost, risk, resources, quality, scope, and schedule. Of course, the 3 main constraints that we're always concerned about. Can anybody guess? Anybody guess? 3 main constraints? Somebody out there got it. Probably all of you, I would think by now. Time, cost, and scope, or schedule, cost, and scope, right? The requirements. That iron triangle, right? That is the constraints we're always making trade-offs to manage. Now, to do that, I can do some basic project planning, right? Which is an industry standard for scheduling a project today. The plan consists of activities or tasks that are logic-based. So these activities tied together such that the forecasted dates in the schedule move with the current status, right? So resources can be assigned to activities, and these resources then move in concert with the updated status. This is an accepted method for resource loading your schedule and is the most widely utilized method in engineering, developmental efforts, etc. In fact, as project manager, I use a term called even though an activity is scheduled, I don't allow it to start until I have given formal permission because schedules are ebb and flow, right? Resource loading schedules is definitely a trend, and it's gaining momentum, right? So, in fact, the Defense Contract Management Agency, some of you may know it as DCMA, they have a 14-point checklist, and one of it is the schedule resource loaded, right? So it's a real thing. It's useful. Loading resources against each task or activity does take time and discipline to complete and maintain that plan, right? The reality is that you're going to do it anyway, so you might as well do it in a formal way and share it, right? It's communication tool at that point. And you see in the picture that I can I can list activities and load resources over time, or I can list the resource and put the activity that they're on, right? A couple of different approaches to doing that. Okay, this is a picture, a bigger picture from the literature that we're reading about a resource usage calendar. I just thought it was interesting, would share that with you. Okay, so resource leveling, right, which is really less hands-on management is required in the resource leveling. We may be able to use just-in-time inventory when we do that, right? Just in time. As soon as I need it, bam, that's when it arrives. It's going to improve morale because it's going to share the work as you level it across a period of time. And so you're likely to have fewer personnel problems. When an activity has slack, we can move that activity a bit to shift slack. That's float. That's a little extra time. What has no extra time are activities on the critical path. That's why we call it a critical path, right? But if it's not, if it has some slack or float, we can move that activity a little bit. If Sue calls in and says, hey, I'm feeling sick today, and her activity had 6 days float because it wasn't on the critical path, I say, great, take the day off. Is there anything I need to know, or can I talk to your team for you? No, we got it. They know what they're doing. I'll be back tomorrow. Great. Take the day off. Thank you very much. Right? And so this scheduling calculation involves utilizing float or increasing and decreasing the resources for specific activities. And what we're trying to do is any peaks or troughs or in our resource usage are smoothed out. Right? This does not affect the overall duration of the project. And it is also known as limited resource scheduling. Some of you may have heard it like that, right? So really, what is the difference between resource smoothing and resource leveling? They sound the same. They are close. There's a razor-thin margin between the two, really. But resource smoothing is used when the time constraint takes priority. So the objective is to complete the work by the required date while allowing peaks and troughs in the resource demand, right? So resource smoothing is when the resources are unevenly allocated. And so resource smoothing does not touch activities on the critical path. So bottom line, here's what you really need to know about the two of them. Resource leveling is used when resources are under or over allocated, right? So you want to level them. And resource leveling is used when the limits on the available resources are paramount. So as a result, resource leveling can be applied to activities on the critical path. But if you're resource leveling, you're working with activities on the critical path with zero float or zero slack, which means that it may extend your project plan. Now here's just a quick chart that shows the difference between resource leveling on the left and resource smoothing on the right, and you're welcome to study that. So resource leveling, there's this sense of uncertainty, right? That you have needs and they're fluctuating over time, and so I want methods to address them to try and do this. So we can fix this lack of resources through resource leveling and resource smoothing. These are good approaches. So we may shift resources between non-critical tasks to any critical path or task, right? We can try to reduce resources as needed, maybe to save budget money in one place while we look elsewhere to add, right? We can prioritize the deliverables. So we can split the project outcomes into phases, and that may sometimes helps us. And sometimes we just get new resources. If you have a budget, you need to get new resources. That's doable. There's also contracting that is possible, right? Now, the last bullet that says that schedule scarce resources between 85 and 90% capacity. I personally, on my experience, I don't disagree with that, but I personally, in my experience, feel that I schedule scarce resources at about 75%, and I also consider experience in that. Now, constrained resource scheduling, there's a heuristic approach and an optimization approach. Just so that you know, a heuristic, as we discussed in previous conversations, is a rule of thumb, right? It's an approach. It's a rule of thumb in general. And optimization is more of a mathematical approach. So another thing that we can do here then, in response to the complexity of scheduling in this environment, right? We have computer programs that have been developed which schedule job assignments using pre-programmed heuristics, or these rules of thumb, to resolve resource conflicts. One of the more effective of these is called MNSLIC, which is minimal total slack, right? Really tightening down your schedule, minimizing the slack, MNSLIC. And so scheduling by this rule is accomplished as follows. So when activities are compete for resources which are not available in sufficient quantities to schedule all the activities simultaneously, so we schedule those activities with the least amount of slack or total float as determined by our critical path problem. So the heuristic method, so scheduling by this rule is accomplished as previously discussed. Okay, and at the same time, we have common priority rules, right? We said prioritization becomes a focus, and this is treated in the book. I would ask you to read through that, but it's a great list to prioritize. Okay, continuing with the heuristic approach. So as I said, heuristics such as MNSLIC rule, these computer programs have been widely adopted for scheduling jobs when resources are limited because they rationalize the scheduling process and they make it manageable. So they have the advantages of being simple to understand and easy to apply and very inexpensive to use, these adopted computer programs, right? The difficulty in relying on heuristics methods, however, is that there's no guarantee that the schedules developed are of the minimum duration, right? So you want to keep your eye on that. And then, of course, we had optimizing methods. This is deciding that the declining cost of computing is really made optimizing methods possible, right? So there's this proliferation of mini computers that have removed some of the financial constraints so that now any business can use them, right? And so techniques now exist that can be used to provide optimal or near optimal solutions to industrial or engineering or other resource-based scheduling problems. In the PMBOK guide, they will refer to this as a scientific approach. They call it modeling or simulation, right? Where you're using a computer-based simulator to execute your assessment of the scheduling needs. Okay, so we're going to stop there, come back with just a couple more slides talking about Elihu Goldratt and critical chain.